Welcome, everybody. I'm David Edelsohn, here with Tom Stellard. Give you a little bit of background about myself. I'm a member of the GCC steering committee. I've been involved with GCC for decades. I was part of the group that actually created EGCS, the fork of GCC, and then re-merged that back together with GCC, where the EGCS group became the official maintainers for GCC. So this talk is about somewhat of the history of that and how GCC is developed for its release engineering and development process, and comparing and contrasting that with the way that LLVM performs its development and release, and to learn from that and understand the way that GCC and LLVM are consumed, created in different ways and consumed in different ways, and ways to be able to maybe adapt and learn best practices from each other. Everybody else know who Tom is?
I'm Tom Stellard, so I'm one of the release managers for the project. I work at Red Hat.
Great. So the outline of this talk, I'm going to give a little bit of information about the background of GCC, the GCC development process, and Tom will talk about LLVM and the LLVM development process, and then talk a little bit about the insights and the differences between the two of them. So first of all, history. GCC, not going to go into all the details, but it is the compiler for the GNU project. It, for many years, was the system compiler for BSD, that switched over to LLVM. It's still the system compiler for Linux, and the major Linux distributors still use GCC as the system compiler. A little bit of the history of the development, and the important things are that after the EGCS remerger with GCC, there was a release called GCC 295, which was the first release where the EGCS community was in charge of the GCC releases. And one of the things that happened is after that official GCC 2.95 release, Red Hat actually created another release of GCC that they were using internally that was called GCC 2.96 RH, which was similar to, but not exactly the same as GCC 2.95, and actually caused a lot of issues. I mean, it was open source was available, but not quite the same as the distributions that others were using. And that was an important learning experience for Red Hat and for the GCC community to never do that again. And so what happened is with the GCC 3 release, which was shortly after that, with major new features in the compiler, and then the new development process, which was very much driven by the needs of Red Hat and SUSE to some extent. And so this development process was, as Red Hat and SUSE were the very important contributors to the GCC development itself, were very instrumental in the design of this release process to benefit them and their leads as major Linux distributors. So the development model for GCC is a structure of a steering committee, which is somewhat involved with the leadership of, but not defining the strategic goals. It's very much community driven. We have a group that GCC appoints the maintainers and the release managers. We now have a release manager from Red Hat and SUSE that are core maintainers. They are also what we call global reviewers. Then there are maintainers of the individual ports of GCC, which are the targets. And there are maintainers for various features or combinations of features in the compiler, and general contributors to this. GCC, just to get a sort of a snapshot, GCC in 2023 had about over 6,600 commits by about 389 different developers. May consider that large. This is the libraries, libstandard C++. This isn't glibc, this is just the compiler, but Fortran, C++, C, front ends, back ends, targets, and the runtime. And so one of the main characteristics of GCC is focusing in on stability and on backward compatibility. And that GCC trunk development should always be stable. That doesn't always happen, but the goal is for people to be committing patches that are reviewed and approved upstream, and that it should be stable and not breaking various targets. It has a very predictable development process with open development on a yearly cadence of 7 months of development with any new features going in, then a 2 months that are focusing on bug fixes, and then 3 months that are focused on regressions to be able to ensure that we have a stable release, getting through criteria that the community and the steering committee co-develop with primary platforms, secondary platforms, and that so these tests are both the GCC test suite, which is doesn't have unit testing or very little unit testing. That's it's still in progress, but a very, very, very extensive source code base of C tests that have been developed over the 30 years of the project. Many of these from back in the days when Cygnus was a major SDK for compilers, and bringing in tests for C and C++ and Fortran that continues to evolve, testing all different components from the C level. Sniff tests also for the release that many of the Linux distros, again, SUSE and Red Hat, will actually run and test building an entire distro with the compiler. GCC doesn't have a CI system itself, which is a limitation. So there is a issue with getting rapid feedback. There is this test suite that is user-driven and user-contributed, but there's no good way to tell if a patch actually breaks on a particular platform if it's not being tested by the users, somebody doesn't bring it up. There is a reversion policy that is implemented in the emission more, and so that's partly why there is a focus on the latter end of requiring multiple months to actually get the stability to purge out various regressions that were introduced during the development process. The release model is basically a maintenance for 3 years, so that it's a unified maintenance upstream in the primary GCC repository, that all bug fixes to later releases have to be upstream in the current trunk. In other words, you can't fix something in one of the releases that isn't fixed first upstream in trunk and then propagated down to any continued to be maintained releases in the release branches. And so the releases are also at a regular cadence of 3 months, 6 months, a year, and 2 years of official, what are called FSF GCC releases. And then the Linux distros do continue to maintain the releases upstream in a cooperative manner. There aren't official releases, but often SUSE and Red Hat, if they will find a problem for if they are considering a long-term release for their Linux distro, will continue to put those bug fixes upstream and propagate it into the various release branches. But again, no official releases. And the Linux distros basically choose which GCC releases for their own cadence they will use, and that will often get more extensive testing of GCC for that particular Linux release. So head over to Tom to talk about LLVM.
Sure. OK. Yeah. So let's start first with the contribution process for LLVM. So historically, our process has been a little bit less structured with GCC. We had code owners, but their roles were somewhat unclear, and there wasn't really a well-defined decision-making process for the project. But fortunately, this has changed over the last few years as we've adopted a more formal decision-making progress a few years ago. And just recently, we approved a new governance model that will include elected area teams for the different sub-projects, and as well as a project council to help facilitate the technical decision-making for the whole project. And so this is really a must-needed change for us because we have a very high rate of change and a lot of individual contributors. So when you compare with GCC, we have about 5 times as many commits per month and about 5 times as many unique authors per month. So getting this a little bit more formalized, I think will be good long-term for us. Despite all this rapid change, though, there's a very strong emphasis in the LLVM project on keeping a stable main branch. So this is achieved by having sort of a revert first and discuss later policy for breaking changes, as well as a large cluster of build bots that do continuous post-commit testing. We do also benefit a lot as a project from downstream users that pull and test the main branch regularly, and they're able to run a little bit more extensive tests than we can do in BuildBot. And so one part of our development model that is very different from GCC is that we continue to do feature work in the main branch while we stabilize code for the next release in the release branch. So part of the reason we do this is that many downstream users, they aren't really interested in our release branches and really only care about what's in main. So if we were to freeze the main branch for a period of time like GCC does, we would end up with a lot of very unhappy users. So we also have a very predictable release cycle that lasts for 6 months. So after we branch the next release from main, we spend about 1 month of time stabilizing the branch leading up to the very first X.1.0 release. And then after that, we do about 3 months of bug fixing with 1 release every 2 weeks during that period. Now, we do actually have a proposal to extend our bug fix release timeframe from 3 months to 5 months for this current LLVM 19 cycle. And so what that would mean is that effectively we would always have at least 1 supported release of LLVM that is getting bug fixed. So currently there's like a 2-month gap between when we stop supporting like the old release and before we do the next release. So with this new proposal, that gap would be closed and we'd have something that was, we'd always have a release that was supported by the community with bug fixes. And then over the past, I would say 7 or so years, our release process has really transformed a lot with the main goal of making the releases as low cost as possible. So we went from doing everything pretty much manually, all the backports, all the testing, all the issue tracking, to now we have a mostly automated backporting process. We have a status tracking project on GitHub and even CI testing for the release branch. And being on GitHub has really enabled us to do a lot of great things in this area. We used to only be able to do 1 bug fix release for every major version, but now we're doing 6, and with this new proposal that I mentioned, we could be doing 10 or more. So in my role at Red Hat, I lead the team that packages LLVM for Red Hat Enterprise Linux and also for Fedora Linux. And I would say that the biggest challenge we have is that there are really 2 different deliverables in our builds. So we have the tools like Clang, Flang, ClangD, et cetera. And then we also have the libraries. And in Fedora, for example, we have 31 different packages that depend on either the Clang or the LLVM libraries. So if we ever try to push a new version of LLVM or Clang into the distribution, all those packages that depend on the libraries will stop working. You won't even be able to install them anymore. So this not only prevents us from pushing new versions of the libraries, but it also prevents us if we want to push new versions of just the tools too, because they both come from the same package. And GCC doesn't really have this problem. So you can push a new version of GCC into the distro and all the previously built packages will just keep working. And the reason that we have this issue with LLVM is because the C++ libraries that we ship in our project, they don't really have a stable API or ABI between the major releases. So applications always need to be rebuilt when there's a new version of LLVM. And in many cases, those applications will require source changes just to keep up with the latest changes in the API. So what we do to work around this, we end up providing multiple parallel installable versions of LLVM. So for example, right now you can install LLVM 19 in Fedora, 18, and a couple other older versions as well. This isn't really ideal from us for a support version. I don't really like having to support multiple versions at once. But it's something that's a necessity for us in order to keep some of the packages working that really need those older versions. Okay.
So wanted to now talk a little bit about the differences between how these versions in GCC and LLVM are targeted. That the Linux distributions and the vendor compilers are very much focused on sort of long-term system horizons. And the Linux distributions are used in a way where it's a shared system often. And as I mentioned, GCC, the GNU toolchain, and the Linux distros co-evolved that way. I mean, LLVM has been around for a very long time, but in some ways, it's not that it co-evolved for containers, but in many ways, the way that LLVM works from my perspective is sort of better targeted or is easily consumed by something like containers, like microservices, where one builds an application, a single purpose container, and one does A/B testing, rolls it out. If it doesn't work, rolls it back. But one is able to have this continuous delivery, continuous updating of the application with the toolchain. The toolchain doesn't necessarily need to have a long-term support because you're continually rolling in new applications, whereas GCC being evolved for Linux and Unix, that sort of history, where it's a shared system, you have shared dependencies in a multi-purpose, multi-programming system. So there's that different consumption model, and that these compilers, again, not GCC definitely evolved, co-evolved for that purpose. Not that LLVM evolved for that, but LLVM is more easily usable in this container purpose. So a little bit of comparison, what I think are the strengths is that GCC, as we both mentioned, has a lot of stability for better or for worse, that it has this long-term support, multiple years, that again, for the official releases and then the Linux distros themselves provide even more stability and support for, I think RHEL 7 was still GCC 4.8 release. I mean, so you have which is a decade ago. So long periods of time where not that there's a lot of changes, but that it is officially supported by those distros and provides that very stable environment ABI. That's the base system ABI for all of the applications to use. And as Tom mentioned, similar to LLVM, there were these GCC toolset, I think it was in Red Hat, where one could install newer versions of GCC in parallel, but the system compiler and the base level for the Linux kernel builds was that very stable version. And also the GCC is able to compile an entire Linux distro, which is not an easy feat. That I think there still are some gaps with the ability of Clang to truly be able to build correctly. Just be able to build all of the various applications. So that's a purpose that GCC is still relied on by these Linux distros. The weakness is that obviously, exactly as Tom mentioned, this development style does inhibit with the freezes, does inhibit the development innovation pace and the ability for people to contribute and get their changes in very rapidly. And it is a somewhat rigid development process. Again, I'm not going to speak so much for LLVM, but one can see that it has a lot of benefits with innovation, flexibility, a very modular design, and so a lot of benefits that have obviously served it very well with this incredible development, but the lack of long-term support and as we're mentioning, the ABI and API stability itself, if you're using LLVM downstream in other projects, that each LLVM release is not guaranteeing its internal interfaces, external interfaces to be the same, which causes churn and causes difficulty with updating. So the impact of adoption is this long-term support, stability ABI, backward compatibility, there are many vendor compilers now. The ARM compiler, LLVM technology, based on LLVM technology. IBM's OpenXL compiler, based on LLVM technology. And so they're all providing Apple, Clang, based on LLVM. But they're all implementing this long-term support independently and dealing with the issues of how to backport it and when to cherry pick this. And so this is creating a lot of duplication, that all these teams are doing this independently as opposed to GCC, which has a coordinated single environment. So the unified maintenance ensures consistency across all the distributions, all the users of GCC. So while the system compiler that Red Hat and SUSE and Canonical have invested heavily in this tool chain and defined it that way, so the question is how to make LLVM more effective as an alternative system compiler. How can it in turn provide this long-term support without stifling innovation?
Sure, thanks. All right, so just quickly, some challenges that I think we have that make LTS release more difficult for us is I don't really think we're set up to have any more than 2 releases in flight at the same time. And I think some of it comes down to the developer bandwidth for backports and fixes, because every fix we merge to a release branch gets reviewed by a code owner or someone else who is familiar with the code. So it's hard enough to find enough people to do that, to get stuff in the main. But if we have to re-review stuff over and over again for the different branches, I think that's going to create a lot of work. And also, because in our project, as I said, not everyone really cares about the release branch. It's understandable that people may not have the motivation to help out. So I think that's a little bit of a challenge for us if we're looking towards an LTS release. I think the other problem is just schedule alignment. I think this is already an issue today, even though we have relatively frequent releases, at least compared to an LTS schedule. Some people want to use the release branch, but it doesn't align with their internal schedule, so they just end up pulling from main anyway. So I think like with LTS, this problem just gets worse because we have less, we might have an LTS release every 3 years, and it just makes it that much harder to align. And also, I think just as a practical consideration, the project gets about 40,000 commits per year. So if you have an LTS branch that is like a year removed from main, backporting changes can start to get really, really difficult. And you can imagine how that would look like 2 or 3 years out. So I think we have some challenges that make it a little bit more difficult for us. But if we did decide to do an LTS release, I think there's some things we'd have to decide first, like how often we want to do it, how long is it going to be supported, what does that actually mean to support the release, what kind of bugs were fixed, et cetera. So I think it's definitely something that's worth having a conversation about, and I'd love to hear people's opinions about that. We'll take questions in a minute, and we also have a roundtable coming up tomorrow.
Next slide.
Oh, it's the next slide. Okay, that we can discuss this further. So with that, let's open up for questions.
Regarding the LTS release, do you have a guess of how many full-time engineers it would take?
To maintain an LTS release for
Yes.
LLVM? Well, it depends on what you mean by maintain. So that could take a number of, that could look a number of different ways. Is it, are we going to try and backport every bug fix that lands in main into the LTS release? Are we just going to respond to user queries? I think it's probably very difficult to put an estimate on it because it's potentially a very large scoped problem, I think.
Yes, and that's why I'm asking about the guess. Is it 5, 10, or 50 people or more?
I don't know. That's a great question. I really don't know because, like I said, I think there's too many factors, and it depends on what you want to get out of it, I think.
I'm asking because there is a genuine interest in LLVM LTS from more than one company, and the managers are asking how many people.
Well, if the manager is asking, then the answer is 50.
Other questions?
So next slide. So tomorrow, 2:15, if you want to come to a roundtable, we have scheduled to continue this conversation. So thanks very much.
Let's thank the speakers.